Hi everyone, my name is Guillermo and I'm educator and quantum researcher here at Xanadu. In a previous video we talked about the concept of a Q-node, that is the set of a quantum function and a device. The quantum function is all these operations that we want to run for a specific algorithm, and the device is the place where we are going to run all these operations. But what that means with where? Today we are going to talk about this concept and all the possibilities that PennyLane allow us to do with that. We can divide our devices in two main groups, the real quantum hardware and the simulator. In the long term, probably what we really want is that all our circuits are executed in real hardware, but in the meantime, we are going to use a simulator. We can understand it like a program that tries to copy the behavior of a quantum hardware in a classical computer. And we are going to have some advantages to do that. For example, we are going to have access to all the wave function, so we are going to get more information. However, if we measure in a quantum computer, the wave function is going to collapse, so we are going to lose some information there. Furthermore, in a simulator, we are not going to have noise. And actually, in all the real quantum hardware, this is a very big problem. So for study some small algorithm, it's very interesting to work right now with this simulator. Okay, so why don't we use always a simulator? I mean, we have access to the whole wave function, we have not noise. Seems that it's going to be always better. However, these programs are not efficient, and the number of operations that we have to do through all the algorithm is going to grow exponentially with the number of qubits. To give you a main idea, in your computer, probably you can simulate around 20 qubits, but this is not enough to get some advantage in the real world applications. Okay, so let's start showing the devices that comes with PennyLane. Probably the most famous one is the default qubit, that is a state vector simulator. So in order to use it, the first thing that we have to do, as always, is import our library. Import PennyLane as QML. After that, we will define our device, that the name, as we say, is default qubit. And after that, we say the number of qubits that we are going to use. To do it easy, let's guess we only use 1 qubit. After that, we have to define our quantum function. It means the set of operations that we want to use. In that case, let's say the circuit, and we are going to apply only a Hadamard gate. Let's return, for example, the probability of get the different basis states. So now we have, in one hand, the quantum function, and in the other hand, the device. But let's say that we want that this quantum function have to be run in this specific device. So to do that, we create the Q-node, and we pass the device where we want to execute the circuit to be run. So now, when I call to the circuit Q-node, I'm going to get the result. In that case, the Hadamard gate create equal superposition, which is 0 and 1, so the probabilities to see the get 0 or the get 1 is going to be the same. Default qubit is a device that is written in Python, and we know that Python is not the faster of the programming language. So for this reason, we decide to create another device that is called the Lightning qubit. Lightning qubit is just the same idea, but in the backend is written in C++, that, as we know, is a very fast language. These two devices that we just see, the default qubit and the Lightning qubit, assume that we know with certainty what is the quantum state we work with. However, there are another situations, like working with noise, where we cannot guarantee this. So we have to work with mixed states. A mixed state is just when we have different quantum states with different probability, and this is something we can work with in PennyLane too. In that case, we have to define the default mixed and we are going to inherit all the same operations of the other devices, but with some extra more. To put an example, we have the bit flip operator. That this means that with third time probability, in that case the 50%, we are going to apply a Pauli x over the qubit. We are going to do a flip. In that case, if we run the circuit, we are going to get the same solution. With 50% of probability, we will see they get 0, and with 50%, they get 1. But they are completely different in state, and I invite you to think what could be the difference of these two states that we just see. Okay, so with that, we have a main idea of different devices that we can use. However, one question that we can do is, okay, why we call everywhere to the qubits wires? I mean, in the device, we say that we are going to use 1 qubit, but we can read wires equal to 1. Or to specify to a gate where it's going to be applied, we again write wires. Well, actually, this is because PennyLane doesn't work just with qubit. There are another kind of quantum computer with a different unit of information. This is the case of the quantum photonic computer, where the basic unit information is the Q mode. They work in a very different way, different gates, different space, but there is something that we can simulate too. And actually, to do that, we have to define the default Gaussian device, that in that case, we are not going to enter in details in this video. So with that, you can start to see how useful is PennyLane. We have a lot of different devices for different situations. However, this is not the only strength of PennyLane. Actually, one of the most important points of this library is how easily we can use devices of external providers. So we are going to go to the website to understand it a little bit better. So if we go to the main page of PennyLane.ai, we are going to find this interface, and in the top we are going to see different options: quantum machine learning, demos, install, plugins. So if we go to plugins, we are going to see first of all these devices that we just talked about: the default qubit, lightning qubit, default mix, default Gaussian, and under that we will see the plugins, this access to different devices of different providers. For example, we have the Qiskit devices of IBM, of Amazon, Strawberry Fields, that is our photonic computation library, Cirq of Google, Microsoft, and so on. So for example, if we click in one of them, let's say Qiskit, we are going to see the list with all the devices that give us access. Like for example, Qiskit IBM Q, that is the real quantum hardware, or some simulators. So if we click in one of them, we are going to see more information of the device and how we can use it in IC mode. So we just seen the main idea of what a device is and all the possibilities that thanks to PennyLane we have access to. So I hope that this concept is much more clear. And if you want to continue learning quantum computing, don't forget to subscribe to the channel. Thanks to be there, and I see you in the next video.